Welcome to this comprehensive training video on event systems and delegates in Unity 3D and Visual Studio, designed specifically for beginners. This tutorial will guide you through the fundamental concepts and practical applications of these powerful programming constructs, essential for developing robust and interactive applications. We'll start by exploring how these powerful concepts enable modular, flexible, and maintainable code within your Unity projects. Understanding delegates and event systems is crucial for creating scalable and organized game logic, allowing different parts of your application to communicate efficiently without tight coupling. Think of real-world examples like UI button clicks, where an action triggers a response, or game state changes, such as a character's health reaching zero. These scenarios perfectly illustrate the need for a system that allows objects to react to events without direct knowledge of the event's source. By the end of this video, you'll not only understand delegates and event systems, but also gain practical knowledge on how to implement them effectively in Unity using C#. This will empower you to write cleaner, more efficient, and easily extensible code for your game development endeavors. First, let's demystify delegates. A delegate is essentially a type-safe reference to a method, acting much like a function pointer, but within an object-oriented framework. This means it can hold a reference to one or more methods, allowing you to invoke them indirectly. The syntax for declaring a delegate in C# follows a specific pattern: access modifier delegate, return type, delegate name. This structure defines the signature of the methods that the delegate can reference, ensuring type safety and consistency. For instance, public delegate void myDelegate declares a public delegate named myDelegate that takes a single string parameter and returns nothing. Any method with this exact signature can be assigned to an instance of myDelegate. Using delegates involves three key steps: declaration, instantiation, and invocation. These steps form the fundamental workflow for leveraging delegates in your C# applications, providing a clear and structured approach to method referencing. Declaration defines the delegate type, specifying the method's signature it can hold. Instantiation creates an instance of that delegate type and assigns a compatible method to it. Finally, invocation calls the delegate, which in turn executes the assigned method or methods. Let's see a simple Visual Studio example to solidify our understanding. We'll declare a delegate named stringDelegate that takes a string as an argument and returns void, setting the stage for our demonstration. Next, we create a method called showMessage that perfectly matches the delegate's signature, printing the received string to the console. This method will be the target of our delegate's invocation. Then, we instantiate stringDelegate with our showMessage method, effectively linking the delegate instance to the method. Finally, we invoke the delegate with a sample message, observing the output in the console, which confirms the delegate's successful execution. Delegates can be single-cast, meaning they reference only one method at a time, or multicast, allowing them to reference multiple methods simultaneously. This versatility makes delegates incredibly powerful for various programming scenarios. You can combine delegates using the += operator to add methods to their invocation list, and remove methods using the -= operator. This allows for dynamic management of method subscriptions, enabling flexible event handling. Now, let's move on to events. Events are a special kind of delegate primarily used for notifications, allowing a class to inform other classes when something significant occurs without needing to know who or what is listening. In the context of events, we refer to the class that raises the event as the publisher and the class that handles it as the subscriber. This publisher-subscriber model is a cornerstone of event-driven programming, promoting loose coupling. The syntax for declaring an event in C# is straightforward: access modifier, event, delegate type, event name. This declaration establishes an event that can be raised and subscribed to based on a predefined delegate signature. An example would be public event myDelegate myEvent, where myEvent is an event based on our previously defined myDelegate. This means myEvent can only be associated with methods that match myDelegate's signature. Key differences between delegates and events include invocation scope. Events can only be invoked from within the class where they are declared. This restriction ensures that only the publisher can trigger its own events, maintaining control and encapsulation. Furthermore, subscribers can only add or remove their own event handlers. they cannot directly trigger the event or access its underlying delegate. This strict control prevents external classes from misusing or accidentally invoking an event. Events provide a crucial layer of abstraction and prevent direct delegate access, promoting encapsulation and leading to cleaner, more maintainable code. They enforce a clear separation of concerns, making your applications more robust. Let's demonstrate with a Visual Studio example. We'll declare a delegate myEventHandler that takes an object as the sender and event args for event data, a common pattern for event handling in C#. Then, we create an event myEvent based on this myEventHandler delegate within our publisher class. This myEvent will be the mechanism through which our class notifies subscribers of significant occurrences. We'll implement a method on myEventRaise to safely handle the event invocation, ensuring that subscribers are notified only when the event is not null. Additionally, we'll create a simple handler method in a subscriber class that displays a message when the event is triggered. Finally, we'll demonstrate subscribing to the event from a separate class and then raising it from the publisher. We'll observe the message in the console, confirming that the event was successfully handled by the subscriber. Moving into Unity, its built-in event system is crucial for handling input and UI interactions, providing a robust and flexible framework for responding to user actions and game events within your projects. Key components include the event system itself, which acts as the central dispatcher, managing selected game objects and coordinating with various input modules to process user input effectively. Input modules, like standalone input module for keyboard and mouse input or touch input module for touch-based devices, handle the specifics of input detection and manage the state of events, translating raw input into actionable events. Raycasters, such as Graphic Raycaster for UI elements or Physics Raycaster for 3D objects, play a vital role in determining what the pointer is currently over, enabling precise interaction with different types of game elements. Let's create a simple UI button and handle its on-click event directly in the inspector, showcasing Unity's intuitive visual event configuration. This method is ideal for quick prototyping and straightforward UI interactions. We'll add a script to the button GameObject that defines a public method. This method will contain the logic we want to execute when the button is clicked, making it accessible for the on-click event. In the inspector, we add an entry to the button's on-click event list, then drag the button GameObject itself into the object field. Finally, we select our script's public method from the drop-down, establishing a direct link between the button click and our custom logic. The event trigger component offers even more flexibility, allowing you to handle a wider range of UI events beyond simple clicks, such as mouse enter, mouse exit, pointer down, and pointer up, providing granular control over user interactions. Now, let's integrate custom delegates and events within Unity to facilitate communication between different game objects, moving beyond the built-in UI events to create more complex and interconnected game systems. Consider an example where one game object raises an event when a specific condition is met, such as a player's health reaching 0. Another game object can then subscribe to this event to perform a corresponding action, like displaying a game over screen. First, define a delegate for the event, such as public delegate void health 0 handler. This delegate establishes the signature for any methods that will respond to the health 0 event. Then, declare an event based on this delegate within the game object that will be the publisher. Public event health 0 handler on health 0. This event will be raised when the health condition is met. Create a method to safely raise the event, for instance, void check health, if on health 0. This method ensures the event is only invoked if there are subscribers. In a separate script, perhaps on a Game Manager game object, subscribe to this event using health script that on health 0 plus equals handle health 0. This line establishes the connection, making the game manager aware of the player's health status. Finally, implement the event handler method, like void handle health 0 debug log. This method will execute when the on health 0 event is raised, demonstrating the inter-object communication. Unity's Unity Event class offers a convenient and powerful way to create events that are configurable directly in the inspector without needing to write custom delegate declarations in code. This simplifies event setup for many common scenarios. This provides a highly visual and user-friendly way to connect actions and responses within your Unity projects, allowing designers and developers to link functionalities without extensive coding, fostering a more collaborative workflow. To recap, we've covered delegates as type-safe method references, events as a specialized form of delegate for notifications, Unity's built-in event system for UI and input, and how to implement custom events for inter-object communication. These tools are invaluable for creating loosely coupled, modular, and maintainable code, making your game development process more efficient and your projects easier to scale and debug. Embracing these patterns will significantly improve your codebase. We encourage you to experiment with different scenarios and explore the vast possibilities that events and delegates offer in your own Unity projects. Practice is key to mastering these concepts and integrating them seamlessly into your development workflow. For further learning, consult the official Unity documentation, which provides in-depth explanations and examples, and explore various online tutorials to deepen your understanding and discover advanced techniques. Continuous learning is vital in game development,